Welcome to RotaRail Tech Series Episode 6. Today we're going to talk about some of the electrical changes we're making on the car, including upgrading batteries. So yeah, don't forget to give us a like and follow our page to keep up with what we're doing. So last season we ran a single one of these batteries on the car. It's anti-gravity, 16 volt, about 20 amp hour battery, 500 cranking amps. So last year we had an external battery pack for the starter, and we were just using this to power the ECU and the CDI and all the other stuff on board. And the reason for that, we were trying to keep the weight down, so had the external starter. But for this year, just to make things easier in the staging lanes, also give us a bit more battery capacity on the car, and let us, start the car without having to plug in a battery pack, which also makes us technically legal for top dragster. We've added a second battery, so I'll cover that in a sec. But yeah, so using one of these are pretty cool batteries. They're only a couple of pounds, 16 volts, charge from flat in about 40 minutes, so 45 minutes or so. So they're a pretty good battery. We've used these before, and yeah, anti-gravity helped us out, supplied us with a couple of batteries. So starting at the front of the car, here's our new battery box for this year. So as you can see, we've got it's mounted in the front of the car, in front of the fuel tank, and it's made this out of 8-inch aluminium, and it's got a lid that goes on top, obviously screwed on, so it's all sealed, and it's on vibration dampening mounts and stuff, and I've got an extra mount to go on the front here. It just ties it in. So the batteries itself, so it's got two of those 16 volt batteries in there, so they're wired in parallel, so it gives us 1000 cranking amps. So the starter itself pulls about 360 amps. It's only I'll show you that in a minute, it's only a little Chevy mini starter, but at 16 volts it pulls more amps, obviously. So with 350 odd amps going to the starter, and then with the CDI and fan and water pump and the ECU and coils and stuff, it was pretty marginal at 500 amps. So that's why we've added the second battery. And it also gives us, like I said before, it gives us more reserve capacity, basically. So normally anti-gravity doesn't kind of recommend running batteries in parallel or series, but yeah, it seems to work fine. So we actually, our remote battery pack last season, we had both these batteries in there, and it worked fine, didn't have any problems with it. So that's how we've got on the car this year. So we've got our tie down clamp obviously in the box, and then both batteries are fused into a bus. These are made up out of copper bus bars, so got these in the box done by Oshcut. So I catted all this up and they all bent it up and everything, and then I just kind of tigged in a couple of bits and everything. These are actually these are solid state relays. So there's 5 of these on the main power bus, and that gives me, each of these is 100 amps continuous, 150 amps peak. So they're pretty cool. They're from a company called Wave Labs. They're 30 odd bucks each. So these, yeah, like I said, you push 500 amps continuous through these, and 750 for up to a minute. It's pretty neat. So got those in parallel there, and then on the other side, because we put an alternator on the car, we're running a diode bridge and another relay for the charging side, and that basically isolates the alternator off the kill switch. So these are wired into the kill switch, as well as the main power. So it completely shuts off the battery on both sides, kills the alternator, car stops dead. That's pretty neat. And then it's a couple of fuses on the front, obviously for charging, just keep it topped up. And then the actual kill switch side, instead of running a big fat kill switch on the back of the car, we actually run a low current switch, and I'll show you the switch in a sec. On the dash, there's one on the dash and one on the back of the car. So how this works is that there is 12 volts which is fused going out through here to the switches, and then comes back, and then that goes into this little solid state relay, and this then switches these ones. And the reason that it we've done it like this is that if you are switching to ground and you have some chafe and the wire grounds out on the chassis, it won't turn off. Or you have a fire and it melts insulation, grounds out, whatever. So the way that we've done it is that it's 12 volts here. So if this grounds out the chassis, the fuse will blow, cuts off the battery. So there's no safety issue with the fire or chafe on the wires or anything. The wires are all protected anyway, but it's just a safety thing. We had no problems getting this past this setup past NHRA in Div 6 here. Once we showed them how it worked, and so that works pretty good. And then we've got obviously coming out of the battery, we've actually got this is some 2 gauge going to the PDM and an earth strip, and that's to power the ECU and the CDI and everything else. Then we've got a couple of cables going down to the starter, and we earth the engine block there as well, and then I think it's 4 or 6 gauge to the alternator, which is pretty fat, but it's it's 10 feet of cable, so I didn't want too much voltage drop down to the alternator. So this is all new for this season, but tested it, all works fine. Pretty happy with it so far. Let's move on down the car. So here's the kill switch on the dash. Just labelled master on off. So that just shuts it off, and then down on the back of the car, there's one there as well, and we've got some sort of stripy shiny tape on there so that the track staff can see it in an emergency, and that just kills the car. Here's the PDM setup that we use, hardwire PDM 15, so it's got 15 outputs. You can push 180 amps through that. It's 20 amps continuous per output maximum, and you can peak at 80. So probably a little hard to tell because it's a bit of a mess at the moment. We're changing a few things, putting a bigger fan on and that. But it worked perfectly fine last season, and integrates fairly well with the fuel check dash. Here's our starter setup down the back of the car. Last season we actually burnt out 2 remote starters. We were just trying to crank it off the front of the crank. So we ended up putting this starter on board. And it's actually a reverse rotation starter. And the ring gear is a 63 tooth one. It's off like a Burt Speedways style transmission. And then we ground the teeth off the front, or the front face, and cut the right chamfer on for the opposite rotation. Got the idea for this off a racer in Australia, Terry Stacey, Todd Stacey. So that's how they run it on their RX-7. So copied that. Once we did this, worked flawlessly. Start the car, no worries at all. As you can see, we also drive the supercharger off here. It's the wheel for our RPM pickup. This just mounts on the front hub. And then we've got the drive for the fuel pump. But this year we're also adding an alternator on. So got a little 100 amp alternator down there, 16 volts. It's actually adjustable, the voltage, so we can adjust it anywhere from about 14 up to 18 volts. So we'll tweak that for the right voltage for the batteries. And I've just got to swap the pulley over, finish up, because we've got some spaces like this that were on this side, so I've just got to cut some new spaces down. These bits are new, obviously, for the alternator, and get this wrapped up. So the reason that we've got the starter on the front of the motor instead of just running a ring gear on the rear is that there's not really any room. So the rear plate mounts up to the back of this engine plate, and then there's basically a taper adapter that the clutch, the CVT fits on. And there's not really room for a flex plate or anything in there. It would space everything out too far, and also it would probably hit the chassis. And then also, if you run a flex plate, you obviously then need an SFI bell housing. So it doesn't really work with our setup. So we basically just run the clutch on, the CVT on the end of the shaft, and provides enough mass to work as a flywheel, but it's not technically a flywheel. So no ring gear on that, just run it off the front, and that's been perfect for us. So here's a new radiator mounted down in the bottom. The engine just sits in behind it here, the sump. So this radiator has about 3 times the capacity of the previous one. And same for the fan. So fan flows about 3 times the airflow. So that will both kind of keep the engine temperatures a bit more stable during a run, but also let it cool down much quicker after, so that we can turn the car around quickly. Above that, on the back of the firewall, we've basically got the fuel injector drivers down there, low impedance drivers, and then we've got the Fuel Tech CDI and 4 coils currently. And this here is for our dial board, which we're just switching over to the Fuel Tech one, which drives off the can, so we can get rid of some of the stuff on the dash. So this intercooler is new for this season as well, and as part of this we wanted to get some decent data off it, kind of pre and post intercooler. So we've got pressure and temperature on the inlet, pressure and temperature on the outlet, and then we've got a water temperature down the bottom as well. And then we've got obviously our blower valve mounted on top. Thanks for watching this episode. Don't forget to give us a like, and we'll see you next time.